Next example. Find the equation of the plane passing through the point in bracket 1, 1, 2 having 2, 3, 2 as direction ratios of normal to the plane. Now in this example, coordinates of one point in the plane are given, direction ratios of normal perpendicular to the plane are also given, and we have to find equation of plane. In which form we have to form equation of plane, it is not given. So we shall form equation of plane in vector form as well as Cartesian form. Coordinates of point. Suppose it is point A, 1, 1, 2. To get equation of plane passing through a point whose position vector is known and vector normal to plane is known, then we can write equation of plane in vector form. So from coordinates of point, we shall write position vector of that point. Position vector of point A, it is a vector directed from origin towards point A. Usually position vector of point written by small. Coordinates of point, they become coefficients of unit vectors I, j, k. 1i plus 1j plus 2. When coefficient is 1, it is not necessary to write. So I cap plus j cap plus 2k cap. I, j, k. These are the unit vectors because each of them has magnitude 1. Direction ratios of normal are given. Two, 3, 2. These are direction ratios of normal to the plane. Then we can write vector which is normal to the plane. In that vector, direction ratios, they become coefficients of unit vectors I, j, k. This is coefficient of I, coefficient of j, coefficient of k in order. So n bar equal to 2 I cap plus 3 j cap plus 2 k cap. Now we can write equation of plane. So here equation of plane, r bar dot n bar equal to a bar dot n. Now put values of a bar and n bar here. R bar dot n bar in bracket 2i plus 3j plus 2k equal to, on right hand side in first bracket, vector a bar I plus j plus 2k dot in another bracket 2i plus 3j plus 2. R bar dot LHS as it is 2i plus 3j plus 2k equal to, on right hand side there is dot product of two vectors, and dot product of two vectors is a scalar quantity. Here both the vectors, they are expressed in terms of ijk. To find their dot product, find sum of product of coefficients of ijk. 1 into 2 plus 1 into 3 plus 2 into 2. So equation of plane in vector form. R bar dot 2i plus 3j plus 2k equal to 2 plus 3, 5 plus 4, 9. This is equation of plane in vector form. In this example, nothing is mentioned. Only asked to find equation of plane. So here we shall write equation of plane in vector form as well as Cartesian form. To write equation of plane in Cartesian form, R bar, it is position vector of point R. Suppose R is point in space whose coordinates x, y, z. Then position vector of R bar. Coordinates of point, they become coefficients of unit vectors I, j, k. So we get x, I plus y, j plus z, k dot in another bracket. Next bracket has 2i plus 3j plus 2 equal to 9. Dot product of two vectors, so scalar quantity. Find sum of product of coefficients of unit vectors I, j, k, x into 2 plus y into 3 plus z into 2. So we get 2x plus 3y plus 2z equal to 9. This is equation of same plane in Cartesian form. So we can convert equation of plane in vector form into Cartesian form. Similarly, equation of plane in Cartesian form can also be converted into vector form. Next example. Find the angle at which the normal vector to the plane (4x plus 8y plus z equal to 5) is inclined to coordinate axis. So in this example, equation of plane is given, but equation does not contain vector quantities. So this is equation of plane in Cartesian form, and we have to find angle made by normal to this plane with each coordinate axis. Means we have to find values of alpha, beta, gamma, that is direction angles of normal. So if we consider alpha, beta, gamma as direction angles, then we have to find their values. Equation of plane, it is in the form ax plus by plus cz plus d equal to 0. Here values of a, b, c, they are nothing but direction ratios. Compare the coefficients. A equal to 4, b equal to 8, c equal to 1. Here coefficient of z not written means it is equal to 1. Here we don't require value of d. We get value of d as minus 5, but it is not required for further calculations. And here values of a, b, c, they are nothing but direction ratios of normal to the plane. Direction ratios or direction cosines, they are for the line or vector. They are not for plane. So here coefficients of x, y, z in equation of plane in Cartesian form, they are direction ratios of normal. Now this is normal, means it is perpendicular to the plane. Now direction ratios are known to us. From that we can find direction cosines. For getting direction cosines, we shall find square root of sum of squares of the direction ratios. Under root 4 square plus 8 square plus 1 square. 4 square 16, 8 square 64, 1 square 1. 16 plus 64, 80 plus 1, 81. 81 perfect square. Its square root is 9. Now we shall write direction cosines of normal. Divide direction ratios by this quantity. We get direction cosines. So direction cosines are 4 by 9, 8 by 9, 1 by 9. And we have to find direction angles, means values of alpha, beta, gamma. Cosines of direction angles, they are direction cosines. So cos alpha, cos beta, cos gamma. So cos alpha 4 by 9, cos beta 8 by 9, cos gamma 1 by 9. Now observe these values. 4 by 9, 8 by 9, 1 by 9. These are not the angles for, these are not the values for standard angles. So we have to write angles in terms of cos inverse. So alpha cos inverse 4 by 9, beta cos inverse 8 by 9, gamma cos inverse 1 by 9. So from equation of plane in Cartesian form, we have got direction ratios. From direction ratios, we have calculated direction cosines. And we have to find direction angles for the normal. These are nothing but direction cosines for normal. And these values, they are not for standard angles. So we have to write angles in terms of cos inverse. Let us see next example. Find the vector and Cartesian equations. Of the plane. Which passes through. a point. Zero, 1, minus 2, and normal to the plane is I cap plus j cap plus k cap. Here we have to find equation of plane in vector form as well as Cartesian form. Coordinates of one point on the plane are given and vector normal to the plane is also given. So first we shall write equation of required plane in vector form. For that we should know position vector of one point in the plane and vector normal to the plane. Here vector normal to the plane is given. We have to find position vector of given point. Suppose given point A, coordinates 0, 1, minus. Position vector of point A we shall denote by small a. From coordinates of point we can write position vector of that point, or from position vector of point we can write coordinates of point. Here coordinates of point, they become coefficients of unit vectors I, j, k. X coordinate, it is coefficient of r. Y coordinate, coefficient of j. Z coordinate, coefficient of k. 0, r. So we need not write term of r. 1 into j. So coefficient 1, not necessary to write. Minus 2. Vector normal to plane is given n bar. I cap plus j cap plus k cap. Now equation of plane in vector form. When position vector of one point in the plane is known to us and vector normal to plane is known to us, we can write equation of plane in this form. Now put values of a bar and n bar. R bar dot in bracket I plus j plus k equal to, on right hand side in one bracket, j minus 2 dot in another bracket I plus j plus k. LHS as it is, R bar dot in bracket I plus j plus k equal. Right hand side, it is product of dot product of two vectors. So it is scalar quantity. As both the vectors are in terms of unit vectors I, j, k, find sum of product of coefficients of I, j, k. First, product of coefficients of I. In first bracket, term of I absent. So coefficient of I 0. In second bracket, coefficient of I 1 plus product of coefficients of j 1 into product of coefficients of k minus 2 into 1. So LHS as it is here, R bar dot in bracket I plus j plus k equal to 1 minus 2 minus 1. Now this is equation of plane in vector form. Same plane we can write in Cartesian form. For that, R bar, suppose it is position vector of point R whose coordinates x, y, z. From coordinates of point R, we can write position vector of point R, R bar. xi plus yj plus z dot another bracket as it is, I plus j plus k equal to right hand side as it is minus 1. Dot product of two vectors. Find sum of product of coefficients of ijk. X into 1 plus y into 1 plus z into 1. So we get x plus y plus z equal to minus 1. This equation contains variables x, y, z. It does not contain vector. So this equation, it is in Cartesian form. For convenience, we may collect all the terms to LHS. So x plus y plus z plus 1. As we have collected all the terms to LHS, what remains on RHS is 0. So vector form can be converted into Cartesian form. Cartesian form can be converted into vector form.
Welcome to Sanjeevani Education Group. Sanjeevani Education Group is the IIT NEET coaching hub which is renowned for producing the rankers in different competitive exams from national level 11th and 12th JEE NEET, Standard 10 NTSC MTSC, 6th and 9 Dr. Homi Bhabha Bal Vaidyanik exam, 5th and 8th scholarship exam, 7th Olympiads along with IIT NEET Foundation for all classes. We have experienced faculty who focus on the academic development of students. So dear parents, hurry up. For admission, visit Sanjeevani Education Group, plot number 13, Aditya Nagar, Gadkhera, Aurangabad, or call 95112 70135 or 95112 66680.